Example 2, finding the roots or factors of a polynomial. Now let's review the steps for factoring a polynomial. Step 1, what is a degree? Step 2, find and list all possible roots. These are your P over Qs. Step 3, test the possible roots using the remainder theorem, or you could use synthetic division. Step 4, the first root is the one with the remainder 0. Step 5, use synthetic division to divide out the first root. Step 6, factor the reduced polynomial. Step 7, write the original polynomial as a product of its factors. Example 2, factor the polynomial completely. Step 1, what is the degree? Since the highest exponent in the polynomial is 3, this is a polynomial of degree 3. Step 2, find and list all the possible roots. These are my P over Qs. My P is -8, my Q is +1. So if I take P, I could have plus or minus 1, plus or minus 2, plus or minus 4, or plus or minus 8. Those are the factors of 8. So all of my P over Qs, 1 over 1, 2 divided by 1, 4 divided by 1, 8 divided by 1. These are really fractions, but since the denominator is 1, it disappeared. Step 1, what is the degree? Step 2, find and list all possible roots. Step 3, test the possible roots using the remainder theorem. You can either take all of your possible roots or all of your possible factors and use synthetic division and see if you get a remainder 0, but I don't like to do that. I like to use the remainder theorem. So when I plugged in -1, I got an answer of -6. That means if I use synthetic division, my remainder would be -6. Since I did not get a remainder of 0, I obviously do not have my first root. Next, I plugged in 1 and I got a remainder 0, which means I have found my first root. So since +1 is a root, x minus 1 is a factor. Those always have the opposite sign. Step 3 was test the possible roots using the remainder theorem. Now, we could go through and test all of them. We might be able to find all 3 factors, but I'm going to go through the steps. Step 4, take the polynomial and divide it by your first factor by synthetic division. So here's synthetic division. X minus 1 is a factor, so +1 goes into the box, and then you take all the coefficients of the terms of your polynomial. Step 1, bring it down. Step 2, multiply. Step 3, add down. Step 4, multiply. Step 5, add down. Step 6, multiply. Step 7, add down. We already knew we were going to get a remainder of 0 because we knew we had found a factor. So synthetic division confirmed that it's a factor by giving us a remainder of 0. So I brought down the x minus 1, and these numbers became the coefficients of my new polynomial of degree 2. So I brought it down from degree 3 down to degree 2. Next step is to factor my polynomial of degree 2. So I could make a diamond problem. I need 2 numbers that multiply to get 8 and add to get 6. Those numbers are 2 and 4. So I have factored my polynomial of degree 3 into 3 real factors.